Morning, everyone. Thank you very much for having me here at the Gemini Live. So indeed, I'm Emile Glorieux. I'm from the Manufacturing Technology Centre in Coventry. But today here, I'm specifically representing one of the projects we're doing. It's a collaborative research project focusing on factory digital twins for automotive industry. It's a collaborative piece of work that is led by Aston Martin, looking at what's the future for factory digital twins. Why do we do this? So there's a lot of challenges at the moment within automotive industry around electrification, because there's a new type of product that is coming. Also, there's new manufacturing technologies, and there's also very uncertain or changes in the market demand moving forward. So we're looking at new parts, new components, new techniques, new material handling, requiring new skills, and also a range of other things. So when we do this piece of work, we're looking at how the factory digital twins need to work to support this moving forward. The one thing we can really say what they need to do is drive and support this continuous change, because one thing's certain, there will be a lot of change in the next 5 years or the next 10 years in this market. So the key to success for an organization is to be able to rapidly adapt and evolve alongside all the other things that are changing. And this is where we see a huge opportunity for digital manufacturing and factory digital twins to support this. So the key for the factory digital twins is to collect this live data from the physical factory, analyze it, and turn it into key functional information that can be fed back to the stakeholders around the organization to, improve operations or support informed decision making. And working together with the industry, we looked at, okay, what does the information need to be? And the key feedback we got was looking at the predictive side of the digital twin. So looking at providing future insight, predicting how next month, next week, or next year might look like. And that will help them to support making decisions and avoiding specific risk or de-risking those decision making, while at the same time also aligning all the stakeholders, so supporting that cross-functional collaboration and eliminating the information silos. And so the key driver is to really avoid making decisions that you then need to correct at a later stage. So that will then require a lot of extra cost, a lot of time and extra effort. So it's that future cost avoidance is really the driver, as well as the reducing the development cost. As the factory digital twin can predict the future, you can support the decision making and be more rapidly adapt to the changes within the industry. So then we've been looking at how can these digital twins look like, and how could they work? And what we see is that a lot of players in this industry already are adopting digital manufacturing. So they'll have a quite advanced digital thread that works across the 5 layers. So there you already have a connectivity stack for bringing live data, analyzing it, storing it, managing it. So we see that there's a huge opportunity there to link the digital twin with the sort of top layers of your digital thread, to collect the live data from your ERP, PLM, MES, really those pillars of your digital manufacturing thread, collect the live data, and then feed it into advanced models and simulations and other tools that you would maybe typically only use for advanced manufacturing engineering. You can now use them with live data that is within the top layers of your digital thread. And then therefore you can predict the future from the latest data, from the current state, and make reliable estimates of how, what will happen tomorrow, what will happen next week. And using simulation tools, but also using visualization tools, because a lot of information becomes available, and it's key to present it in an easy to digest format to a lot of different stakeholders. So we're using simulation tools, but also visualization tools, and then have the algorithms and the connectivity around that. So what kind of digital twins application have we identified? So a first digital twin that we see as crucial is what we call the operational digital twin. So the role of this is to really assess what's going on in the factory today, yesterday, last week, analyze that, and then use that information to predict what's going to happen tomorrow, the next week, the next month. So that really gives you a closed loop to make predictive assessments of, okay, are we on track? Do we need to make certain corrections? And having the advanced operational digital twin manages all of that by bringing the live data and then simulating what will happen next. And that's the most reliable way to predict the future, is to look at the past. And alongside that, we'll have what we call the transformation digital twin. So the transformation digital twin conceptually is the platform that manages and coordinates and directs all the changes that are happening within the factory, from maintenance and services, from introducing new technologies, managing continuous improvement activities. So really looking across all the changes and transformations that are happening and coordinating what happens when, what can happen at the same time, are there any interdependencies, to really drive that continuous change as will be necessary over the next 5 years, and align between all the players in that area. And then a third digital twin we've identified as a concept that is necessary is what we call the knowledge-based digital twin, because as adopting the previous two, you'll be collecting a lot of data and also a lot of key decision points. So when over time you'll be able to look back and understand recurring issues, or when certain solutions work and certain solutions don't work, and have that digest and analyze that and use that as a recommending and identifying when certain problems occur again. You can then have this digital twin suggesting, oh, last time we solved it in this way, so here's a recommendation to do it again. So really be a knowledge base to drive the change. So that really helps to build on this previous experience, but also look at a broader scope as a single stakeholder would be able to do. And a fourth digital twin that would work alongside this is what we call the adaptive scheduling digital twin. And the role of this digital twin conceptually would really be to decide what happens when within the factory, both operationally, both transformation side, and also on other aspects. So it's great to say we're going to continuously change and adapt our factory, but you need to make sure that you minimize the downtime and align all the initiatives and schedule this in time and make sure that there's minimal delays and everything's available in the right time. So therefore, we would have an adaptive digital twin that would work together, collect all the data, understand when certain activities can be performed, and then we can create a good plan and disseminate it to the stakeholders on what needs to happen when to drive this continuous change. And of course, then once you would have these four digital twins, the idea would be to really treat them as four tools within your toolbox and have them interlinked, so they all exchange data with each other, because the operational digital twin needs to inform the adaptive scheduling, what's happening at the moment, and if there's any delays, and backwards as well. So it's not just four independent digital twins. There's four digital twins that are then working together, exchanging information, exchanging data to drive this continuous change. So we currently are architecting and designing these, and at the same time we're also developing a proof of concept of these. However, what we're also doing is, okay, it's great to propose and develop and demonstrate these digital twins, but for industry to adopt them, we need to be able to also show how to manage them over the life cycle, because as we're saying, the factories will evolve and you need to be able to adapt your factory over the next 5 years. You then also need to be able to adapt your digital twin to really evolve alongside your physical twin. So we're proposing a workflow on how to go and manage that life cycle of the digital twin, and really recommending how to update your digital twin when the requirements change or when the factory evolves, and what are the different stages within that life cycle management workflow. So he's proposing on top level 4 stages, first looking at the subsystems, then looking at the digital twin, then looking at doing virtual prototyping to really test and verify, and also training on your new digital twin before you deploy it. And to support that, we're proposing another two concepts of digital twin. One is what we call the software in the loop digital twin, and that's really a platform to virtually test your digital twin in a software in a virtual environment. So I would have synthetic data streams, synthetic synchronization, and then you can test your digital twin virtually without having to interrupt your day-to-day operations. And alongside that, we're conceptually proposing a synthetic data digital twin if in the future, or when in the future we adopt more and more machine learning and AI that require data sets to train, you want to have a platform where you can generate synthetic data sets to already look at how do my algorithms and models behave when data becomes available. So that would be a digital twin that would be able to support and drive that. And then final piece of work we're also doing is to, okay, we propose, as had that, looking at that adoption. So it's great that industry says it's great that you show us what can happen in the next 5 years and how we'd then be looking after it and managing the life cycle. But how do we get there from where we are now? So we develop an additional industrial adoption roadmap to really say, okay, we have this proof of concept that we're developing at the MTC. How do you get this implemented in your factory within the next 5 years? And so we have a generic roadmap that we've mapped out on how to get there over the next 5 years. But then we also have a methodology to adopt this, because each organization has already initiatives going on, most likely around digital manufacturing or virtual engineering. And then certain dots on this roadmap naturally will move around to align with what's already going on. And we have a methodology to support that and work with the industry to tailor a roadmap and also then support turning the strategy into actions and operations within their organization. So just to summarize, we started from, there's a lot of changes happening in automotive industry because of the electrification initiatives, and the key to success is to have a factory that evolves with all those changes that are ongoing, and digital manufacturing and factory digital twins will be key. Not only do you want to have a strong digital twin, but it's important to also look at multiple digital twins working together across different solutions. And at the same time, a digital twin needs to be able to evolve as the physical twin evolves. So therefore, you need to have a good lifecycle management approach. And finally, at the MTC, what we're doing is also then supporting the adoption within industry. So we can roadmap the adoption. The technical details of what we've shown here today will be published in an insights report coming out soon. And then we're also building a proof of concept demonstrator to really get some hands-on experience with the factory digital twins. Thank you very much.
Our next question, Emile, is for yourself. It says, with all the continuing changes in manufacturing in future years, how do you future-proof the data models in the digital twin? How to avoid baking in existing manufacturing equipment and processes, for example? If you click the button, it's gone red? I'll pass Daniel's microphone to you.
Yeah, this is a very good question, a very valid question we also faced, and it's sometimes this will be an issue, and therefore, as we showed on the lifecycle management slide, when this becomes an issue, if you have this what we call the synthetic data digital twin, if you've updated your simulations that are developed from first principles, you can generate some initial data sets for the new changes that you're implementing in the factory. So you have a preliminary data set, albeit synthetic, but it's representative that can kickstart the data-driven models that you're using in the digital twins. So you don't have a delay from adopting digital twins as and when things change. So when you have a new machine in the factory, you can first simulate how that machine will work from first principles, generate enough data to get the digital twin as a model that is maybe then data-driven going, and then as you're deploying it, you collect more data and update it again according to the lifecycle workflow.
Specifically, what are the top two challenges digital twin ecosystems face with respect to adoption and acceleration?
So another point is that with a digital twin, there's a lot of effort needed at the beginning of the adoption journey, installing sensors, buying software, developing databases, and you don't necessarily get that much value from it at that very initial stage. But once you've got a lot of those tools and infrastructure developed, you then really get more and more value and benefits from them with much less effort. So it's really getting over that first hurdle of development effort and implementation effort. And once you have a platform and a system ready, you can then really build on that and go on that journey and really get more and more benefits from them.
This is a question for all our speakers. To what extent are you using controlled vocabulary and naming conventions in your architecture? What standards are you using for these terms? Whoever would like to go first.
So we're adopting an ISO standard. I forgot the exact number, but there's an ISO standard for digital twins for manufacturing, and that represent the layers, and then a naming convention for all the functional elements. And we usually refer back to that when we define an architecture and design the ins and outs of the digital twins we're proposing.
It's just been posted in the chat as ISO 23247 from Jonathan. Thank you, Jonathan.